Well, thank you all for joining in tonight for your very last meeting. And thank you for the opportunity to speak to you about my new book, Feather Trails, A Journey of Discovery Among Endangered Birds. I'm thrilled to be talking to a Philadelphia group since I spent 4 very happy years, long ago, rowing on the Schuylkill River and studying hard at UPenn. So it's a delight to be among Delaware Valley people. Feather Trails is the journey of is a story of my journey into the amazing world of birds. It's in part a personal story about becoming and being a wildlife biologist. The book takes you behind the scenes and it shows you what it's like to reintroduce captive raised birds to the wild in order to save endangered species. And in the process, the book illuminates the threats that imperiled these and other birds. In the early 1900s, coal miners began taking canaries into the mines because the birds were highly sensitive to toxic gases like carbon monoxide. If the birds keeled over, it was a sign to miners to leave the mine immediately. Today, our wild birds are the canaries in the coal mine that alert us to environmental harms through their declining populations or their failure to thrive. Because birds are so visible and vocal, it's relatively easy for us to monitor them and determine if their populations are declining or doing well. When birds are disappearing, it behooves us to try to figure out why, since what's been harming birds is also likely harming other organisms. And when we work to resolve a problem or a threat that's been harming birds, we often help other organisms that have been negatively affected too, including often ourselves. It was great to hear in the beginning of this talk about some chat about peregrines. I'm sure some of you know more about them than I do, but as most of you probably know, the peregrine falcon is a top-level predator that feeds mainly on birds, and it's found on every continent except Antarctica. It occurs in a wide variety of open habitats, from the Arctic tundra to desert and mountain canyons, from coastal cliffs to our biggest cities like Philadelphia and New York. Today, peregrines are found wherever there are suitable nest sites, which consist of high ledges on cliffs, buildings, and structures like bridges. It was fun hearing about the 4 that had fledged on the bridge. But years ago, beginning in the 1950s, peregrines began disappearing at an alarming rate. Their disappearance was first confirmed by a British biologist named Derek Ratcliffe, who completed peregrine surveys in England in 1962. He discovered abandoned peregrine territories and broken eggs in peregrine nests, which was something that had never been seen before. And he realized that peregrines weren't successfully raising young. After hearing about the dramatic decline of peregrines in Britain, a US biologist named Joe Hickey, who'd been a student of Aldo Leopold's and who wrote the first ever guide to bird watching, which is certainly of interest to us. He launched a peregrine survey in the eastern US in 1964. During that summer, biologists checked virtually every known territory east of the Mississippi, from Alabama up to Nova Scotia. And to their dismay, they didn't find a single peregrine. The eastern peregrine falcon had completely disappeared. A follow-up conference in Madison, Wisconsin in 1965 brought together scientists, falconers, and naturalists from around the world. Peregrine declines were reported from 36 countries on 5 continents, and biologists were soon calling the collapse of peregrine populations an ecological disaster. At the conference, several scientists presented preliminary evidence that pesticides might be involved in peregrine declines. A new pesticide known as DDT had been used very successfully in World War II to control insect-borne diseases, and it had come into widespread use after the war to combat agricultural and forest insect pests. The British scientists at the conference showed that peregrines had disappeared from the same areas where DDT and other toxic pesticides were being heavily used. This was fairly tenuous evidence, but it inspired many Madison Conference attendees to go on to study the effects of pesticides on peregrines. Other attendees were eager to see if they could breed peregrines in captivity, something that had never been done before for peregrines or for any other endangered birds at the time. If captive breeding worked, they hoped to reintroduce peregrines to the wild in places where pesticide use was less prevalent. And these two pieces, research and policy work on DDT and captive rearing and reintroduction, ultimately became the two prongs of a massive conservation effort to save the peregrine falcon. Captive breeding eventually was successful, and peregrine reintroductions began in 1974 in the eastern US. By the time I headed to Wyoming in 1991 for my first summer of fieldwork as a biologist, which was releasing peregrines to the wild, the falcon had been reintroduced successfully to the east, and peregrine reintroductions were ramping up in the west. I had only camped a few times when a field partner and I found ourselves living out of a tent in grizzly country on a ranch near Cody, Wyoming. We spent our first week monitoring and feeding 5 captive reared falcons that had been driven to our release site at the age of 5 weeks and placed into a large box known as a hack box. We had 3 males and 2 females, and the females, as with all peregrines and many other birds of prey, were larger than the males. Each bird wore differently colored leg bands so that we could identify them. And as a budding young scientist, I wanted to be objective and name my birds after their color bands, but my field partner overruled me and named them after Egyptian gods and mythological figures. So when I read a passage in a few moments, you'll know that's where the names came from. The hack box was anchored to the top of a small set of cliffs about a 25-minute hike from our camp. You can just see this was our perspective without the spotting scope from our observation spot. Before releasing our birds, we scattered dead quail on the top of the cliff and hack box to encourage the young falcons to stay close and feed once they were released. And on release day, our supervisor removed the front of the box so the birds could fly free. In these types of reintroductions, the first 24 hours post-release are critical and a lot can go wrong. For example, a peregrine in Washington State flew out of the hack box, got carried aloft on a thermal, and was never seen again. We also had to worry about predators like golden eagles and great horned owls, and even adult peregrines, which could target the inexperienced falcons as they took their first flights. Hack site attendants like me were on hand to keep track of the newly released birds, to haze away predators with noisemakers, and to feed the young birds in the days to come. Our peregrines all left the box within a few hours, and luckily they all stayed nearby. Unfortunately, though, during an afternoon thunderstorm, a side door on our hack box blew shut with a bang, which scared the birds, and they flushed into a violent wind and scattered. All but one eventually made it back to the vicinity of the release site by that first night, but you'll have to read the book to find out if our missing peregrine returned. We scattered dead quail on the cliff top each day so that our birds would have plenty of food, and we watched over the young falcons from dawn to dusk. And over time, we really began to see their personalities emerge, which was a lot of fun, and which I convey through my stories in this book. The greatest joy of the whole summer, though, was watching these young peregrines learn to fly. We documented their first hesitant flights and their wobbly landings. And we watched them as they mastered their wings and learned how to use the wind. So I'll just read a 2-page excerpt of Feather Trails that describes what it was like to watch these birds. This is the longest passage I'll read. It's 4 minutes long, so settle in for story time. The birds also spent more time soaring on updrafts of air, joining other raptors in tracing effortless circular paths on these invisible sky elevators. Most entertaining for us, our peregrines began fine-tuning their flight skills and developing their nascent predatory tendencies with endless pursuits and mock battles. Just as playing kittens develop the agility and strength to catch fleet and elusive prey, So too did the falcons' tireless aerial games fine-tune their bodies to respond to the evasive flights of the shorebirds, songbirds, and waterfowl that evolved over the eons to dodge the speed-made predators that hunted them. Though the wild chases had a playful air, these flights, this practice, would determine whether our peregrines became successful hunters and survivors or whether they went hungry and perished. Evenings and mornings were now filled with the falcon's screams and aerial exploits as one bird streamed after another like a small fighter plane locked onto a fast-moving target. The pursued bird dodged and rolled, tucked its wings, and fell earthward in ever more sophisticated, evasive maneuvers. Becoming one with the sky, the peregrines flew with ineffable grace, dazzling speed, and breathtaking agility. As I watched their transcendent flights, I felt my own heart quicken. Transported by the falcon's inimitable aerial prowess, I could almost feel the wind stream behind me, feel every subtle movement of wing or tail that determined my trajectory, my speed, my effortless engagement with the wind. All the while, earthbound, I dispassionately scribbled my field notes, recording our falcon's flights while never taking my eyes off the birds as they traced invisible loops across the firmament, imprinting their movements, their exuberance, their vitality forever in my mind's eye, and lifting my spirits in ways that only such epiphanic sights in nature can. Small wonder that legendary raptor expert Leslie Brown called the unmatched and unmatchable peregrine the prince of all flying birds. Now Ra launched from the clifftop and with strong wind beats chased after Isis, who had glided over him, trailing an invisible wake that seemed to pull the young male into motion. Climbing above her, he screamed a challenge, then drew in his wings and dropped toward her at a steep angle. Cacking in protest, Isis tucked a wing, fell away sideways, and rolled over, presenting her ferocious talons. Undaunted, Ra extended his legs and grabbed Isis's talons in his own. Briefly, the two cartwheeled through the sky, their screams echoing off the cliffs and ricocheting over the valley. Seconds later, they released each other, and Isis circled over the cliff before extending her wings, flaring her tail, and landing with an almost imperceptible wobble. And then another tiercel, those are the young males, materialized out of the clouds, and the pursuer became the pursued. Drawing his wings close to his body, Osiris dropped toward Ra with breathtaking speed and an agility that the larger-bodied, proportionately shorter-winged Isis could never match. Undaunted, Ra dropped to his side, cacking fiercely as Osiris shot harmlessly past him. Leveling out, Ra flapped his wings, found an updraft, and shot skyward. Circling briefly, he dived at Osiris, and the two sped like nanojets out of view behind the cliffs. Ever watchful and attuned to the world around him, Gawain tilted his head to the right, then left, keeping a close eye on Ra and Osiris's antics from the clifftop as Isis preened assiduously beside him. His large eyes seemed to take in the entirety of the heavens, and he watched his fellow tiercels long after I had lost them from view. Although the open skies were now a significant component of our falcon's world, our view of the birds was all too often blocked by cliffs, rocks, trees, and hills. But even when I could no longer see our falcons, the trails they had blazed across the sky still lingered in my mind, and the peregrine's surreal speed and arresting acrobatics, even at this young age, left me awed. Our summer had plenty of adventures, including one of our birds being attacked by a golden eagle. But about 5 weeks after their release, the falcons began to disperse as they learned to hunt for themselves. By 6 weeks post-release, we rarely saw them. After they reached independence, they spent a few more months fine-tuning their hunting skills before embarking on their first migration. And our juvenile Rocky Mountain peregrines, this was in Wyoming again, were likely to spend their first winter in Mexico. Meanwhile, many of the northernmost tundra breeding peregrines leapfrog over wintering Rocky Mountain peregrines and fly as far as southern Argentina or Chile for the austral summer. So it's really quite a migration. About half of juvenile peregrines survive their first year. Radio tracking studies have shown that some falcons are lost to predation, others might die in collisions with cars, buildings, or power lines, and some die in storms or are lost at sea. I could only hope that my young falcons were successful. My time working with them went far too quickly, but it was a life-transforming experience that inspired me to dedicate my career to helping birds. Over time, peregrine reintroductions like mine, which occurred all over North America, were wildly successful. Nearly 7,000 peregrines were reintroduced to the wild in the US and Canada, and falcons began to recolonize their former nesting territories. But what really allowed the peregrine falcon to recover was the banning of DDT in 1972. As a top predator, peregrines killed shorebirds, waterfowl, and songbirds that had fed on vegetation, invertebrates, and seed that were contaminated by DDT. And by consuming lots of these birds over time, peregrines accumulated large amounts of DDE, which is a breakdown product of DDT, in their bodies, and this affected their calcium production, which made the birds lay thin-shelled eggs. Parent peregrines inadvertently crushed their eggs while incubating, so they couldn't successfully raise any young, which ultimately led to the massive population declines. It took many years of dying birds, scientific studies, environmental advocacy, the first environmental lawsuits, and public hearings before DDT was finally banned. But rather than learn from the lessons that the peregrines and other birds taught us, today we're experiencing a similar type of environmental catastrophe with a new class of pesticides known as neonicotinoids, or neonics for short. Neonics are less acutely toxic to vertebrates than DDT was, but they're far, far more toxic to insects, and their widespread use has contributed to what many have dubbed an insect apocalypse. We're currently experiencing an ecologically catastrophic disappearance of our insects. Neonics are known as systemic insecticides, meaning they're taken up by the roots, stems, leaves, fruits, and flowers of plants. So if an insect feeds on any part of the plant, it will either die or become debilitated. Neonics are highly soluble in water, so they're transported by runoff from terrestrial to aquatic environments where they can contaminate surface and groundwater. These pesticides are widely used in agriculture. Seeds of more than 140 crops are coated with neonicotinoids before being planted. And a single corn seed treated with imidacloprid, which is one of the oldest and most widely used of the neonics, can kill a seed-eating bird the size of a blue jay. Consuming about 1/10 of a treated seed on a daily basis during the breeding season can disrupt a songbird's ability to reproduce. More than anything, though, it's the disappearance of insects on which so many birds feed that's the biggest cause for alarm. Over time, neonics have had a tremendous impact on our ecosystems. Neonics are toxic to the earthworms and organisms in our soils, to the aquatic invertebrates that feed our fish, to the bees and butterflies that pollinate our plants, and to the insects that sustain our birds and bats. So unfortunately, despite the dramatic lessons of the DDT era, we're once again overusing a class of persistent pesticides whose impacts are widespread but still poorly understood. The European Union banned the use of some neonics in 2018. Here in the US, though, we've been much slower to tackle this problem, but some towns and even some states are now starting to ban or curtail their use. But to end my peregrine discussion on a happier note, peregrines are doing very well for now. I was encouraged to hear they're doing well in Pennsylvania too. The fastest animal in the world was removed from the US endangered species list in 1999, and there are now about 3,000 peregrine falcon pairs in North America. So this has been a real conservation success story. Things have not gone as well, unfortunately, for the second species that I write about, the Hawaiian crow, or alala, as it's also known, and I'll use those names interchangeably. Most people are astonished to hear that any crow anywhere is critically endangered. Most of us know crows to be opportunistic and able to cope well with people and their habitat modifications. But island living crows that depend on forested habitats are some of our most critically endangered birds. The Hawaiian crow is the most endangered corvid in the world. For those of you who don't know, corvids are members of the crow, raven, jay, and nutcracker family. Despite its name, the Hawaiian crow is more closely related to the common raven than to the American crow. It occurs only on the island of Hawaii, or also known as the Big Island, where it resides in the cloud forest. A good portion of the Alala's forest habitat in Hawaii was destroyed by Polynesian and European colonizers and the animals that they brought with them. In more recent times, the crows were heavily persecuted. Many of them were shot. Their numbers were also impacted by introduced predators and diseases. Hawaiian birds evolved on islands that had no mammals other than bats and no reptilian predators. Their only native predator was the Hawaiian hawk, or eo, as it's known in Hawaii. But people introduced rats and mongooses and domestic cats, all of which prey on Hawaiian birds that never evolved to cope with predators. Tree-dwelling rats consume eggs and nestlings, and if Hawaiian crow nestlings evaded rats and left the nest successfully, they typically spent their first few weeks on the ground, unable to fly. And that strategy worked just fine in a world with no predators, but in a world with cats and mongooses, the fledglings were acutely vulnerable to being killed. Outdoor cats, both feral and domestic, are an additional threat because they carry and transmit diseases. Toxoplasmosis is a cat-transmitted disease that's of particular concern to people and wildlife. It's Toxoplasma gondii is a single-celled parasite that reproduces in feline intestines. It's excreted in the form of oocysts, which are single egg-like cells, in cat feces, and it's eventually ingested by an intermediate host, like a rat. The parasite settles in the form of cysts in the host's brain, and it affects the brain's neural circuitry. Infected rats lose their fear of cats, and they're actually attracted to cat urine, so they become easy prey, restarting the cycle. It's an incredibly ingenious parasite, but bad news. The Toxoplasma gondii oocysts are very persistent in the environment where they can remain for a really long time. Because of runoff, they can contaminate both terrestrial and aquatic environments. Worldwide, toxoplasmosis is one of the most common human parasitic infections. People can become infected by eating uncooked meat or contaminated vegetables, by emptying their cat's litter box if they have an outdoor cat, or by weeding a garden visited by cats or playing in a sandbox that has had cats in them. Growing evidence suggests that the disease may be associated with a variety of mental disorders, including depression, bipolar disorder, schizophrenia, and other diseases. And it's also harmed wildlife, killing several alala and at least 14 critically endangered monk seals. Amazing to me that it harms aquatic animals too. Hawaiian birds have also been decimated by introduced mosquitoes. At one time, Hawaii had no biting insects, and it was truly an avian paradise. But mosquitoes were introduced to the islands in 1826, and they became disease vectors that transmitted avian malaria and avian pox, which were two introduced diseases that were fatal to many Hawaiian birds. Mosquito transmission of these diseases is the major reason why Hawaii is now called the extinction capital of the world. Many of its native birds, especially some of its renowned honey creepers, I've pictured a few of them here, will die after contracting malaria from a single mosquito bite. Most of the native birds that are still left in Hawaii now live at higher elevations where it's cooler and there are fewer mosquitoes. But in our warming climate, mosquitoes can thrive at higher elevations, and soon there's going to be no mosquito-free habitat left for Hawaii's birds. As birds have shown us, introduced organisms, which have especially plagued islands like Hawaii, but have been a scourge worldwide, threaten native wildlife, habitats, and humanity. They degrade biodiversity, they cause extinctions, and globally they cost us about $423 billion a year. When I started working on the Hawaiian Crow Recovery Project in the early 1990s, there were only 12 wild alala left. I was tasked with monitoring the very first group of captive reared alala that were released to the wild. These 5 juvenile crows, we had 3 females and 2 males, had come from eggs that were laid in the wild, and then they were raised in captivity. And once they were old enough, the nestling crows were transported from the captive breeding facility to the release site and kept in a hack box for several weeks before being released into an attached aviary. After about a month in the aviary, they were released to the wild, and I arrived in Hawaii about a week later to help look after them and monitor them. And this was my first impression upon arriving at the release site. A minute later, we pulled off the road into a clearing that held an aviary so immense, so spectacular, that I simply stared at it, wondering at the work that went into enclosing full-size trees in a fortress that was as impenetrable to outsiders as it had been accommodating to its prior occupants. We stepped out of the vehicle onto the wet grass. And then, through the mist, came a strangely euphonic medley of throaty, echoing screams, intermixed with rumbled growls and haunting, evocative wails. I felt my neck prickle. The eerie, commanding sounds seemed to drift out of the floating fog, seemed to embody the lost voices of the trees, the ferns, the vines, released at last from their cellulose prisons. I was hearing the most prominent and unforgettable voice of the Hawaiian cloud forest, that of the ala-la, as the Hawaiians dubbed their singular crow. The bird's native name means cry like a child, but the crow's varied, penetrating, ventriloquistic vocalizations could only come from a child of an otherworldly forest, a creature of a more primal time and place. I stood transfixed, irrevocably moved by the strange but captivating sounds which washed over me like a turbulent wind that spoke of an uncertain future, yet felt full of promise. And I thought, 12. Aside from the young reintroduced Hawaiian crows that I was hearing and was about to meet for the first time, only 12 ala-la remained in the wild. 12 birds to fill these forests with their astonishingly distinctive vocal repertoires. 12 birds to embody the lost world that lingered in this enigmatic place. 12 birds to carry this unique and intriguing species into the future. For a moment, I felt the full weight and the privilege of the task on which I was about to embark. Along with a field partner, I was tasked with tracking the crows through the cloud forest. They were outfitted with tail-mounted radio transmitters, and I also monitored and recorded their behavior. In addition, we provided food for the newly released crows, put out water tubs so they could bathe, and collected fruiting branches for them to feed on. But the crows quickly learned to feed for themselves, to forage for themselves. Ala-la eat a wide variety of forest fruits and they're important seed dispersers. They also feed on insects, which they find under flakes of bark or in clusters of leaves, and they probe for nectar from flower blossoms. This is an adult feeding on native fruit. The ala-la were remarkable. In addition to being very, very entertainingly vocal, Merlin doesn't do them justice. I think they just play one sort of typical crow call for them, but they had incredible voices. They were funny, they were playful, and they were incredibly engaging. They're also really intelligent. They're one of the few bird species that can use tools to secure difficult to reach food items, although that behavior is only being documented in captivity. The crows often foraged, like they're doing in this photo, at the tips of trees. They're very arboreal species, and they sometimes engaged in engaging foot fights where they grasped each other's feet and pushed and pulled at each other until one of the birds fell off the perch they were on. And I'll just read a short section that describes an intriguing interaction between two of our male crows, Kehau and Malama. 5 days into my work with the ala-la, I set out on a gray morning to follow Kehau and Malama, but I felt under the weather. To my surprise, it quickly became apparent that Malama felt that way too. As the other crows busily hopped along branches, poking their bills under bark and into ohia blossoms, Malama rested, perching quietly and preening sporadically. Fortunately, the other ala-la stayed nearby, moving from tree to tree as they foraged. Upon completing yet another behavioral scan, I noted with growing concern that I had recorded Malama sleeping several times, a highly unusual morning behavior. Kehau appeared to be as puzzled as I was by his erstwhile companion's actions. Sidling up to Malama, he made soft mewing calls, then gently preened his sibling's head and neck and delicately nibbled his face. When his ministrations failed to arouse the subdued bird, Kehau plucked an unopened koa flower bud, part of a berry-like cluster that would open into a creamy white powder puff blossom, and pushed it carefully into Malama's back feathers with his bill. No response. Kehau cocked his head, watching Malama, then stretched out his neck, plucked another globular koa bud, and again stashed it with cautious deliberation into Malama's plumage. Still no response. Kehau repeated the process again and again, and still Malama failed to react. Tilting his head, Kehau looked at Malama, murmuring quietly to him. Finally, Malama fluffed out his body feathers and shook them, a comfort behavior known as rousing that often follows a bout of preening, and dislodged the buds. But he remained on his perch, staring at the ground. I just think it's amazing one bird's effort to try to get the other one to behave normally. It turned out that Malama had in fact contracted avian malaria, but we were able to get him medical help and spend a week treating him for the disease. Perhaps my favorite thing about the alala, though, as you already gathered, was the bird's extraordinary voice. The crow has more than 60 different types of calls, and to me, the alala is the voice of the Hawaiian cloud forest. Today, despite years of effort and numerous reintroductions, those forests are silent, and the crow exists only in captivity. Surprisingly, one of the greatest challenges to the bird's recovery has been that Hawaiian hawks have killed so many reintroduced birds. Although the two species coexisted for eons, the balance between the alala and its native predator has been upended. Plans are now underway for reintroducing alala on the island of Maui, where the EO doesn't occur, and these reintroductions may begin this year. So heartbreaking as the alala story is, there's still hope for this captivating bird. And I hope that people will read about it and maybe come to care about this unique crow the way I do, since the bird's future now depends entirely on us. The California Condor story is much better known, though most people are more familiar with recovery efforts in California, and I focus more on condor reintroductions in Arizona. This is the third species that I write about in Feather Trails. This is Condor 210, who is one of the stars of the condor section. And this is the juvenile condor, you can tell by their black head. As many of you probably know, the condor is a member of the New World vulture family, and it's the largest terrestrial land bird in North America with a wingspan of about 9.5 feet. And I love this picture because if you've seen ravens close up, they look like quite big birds, but here they just look tiny compared to this condor. During the Pleistocene era, more than 10,000 years ago, California condors ranged from British Columbia down to Mexico, and then as far east as Florida and New York State. And their range contracted with the extinction of the Pleistocene megafauna, which included animals like Columbian mammoths and giant ground sloths. By the 1900s, condors were largely restricted to Southern California. This was their core range in Southern California until the 1980s. But scattered reports also existed of condors occurring outside California until the 1920s. One of the areas where condors also occurred was the Grand Canyon region. Condors were abundant in this area during the Pleistocene, and they also occurred in Arizona during historic times. For example, 2 condors were seen on the western edge of today's Grand Canyon National Park in 1881. And the last sighting of a condor in Arizona was in Williams, Arizona, which is just south of the Grand Canyon. Condors declined precipitously during the 1800s and 1900s. Shockingly, when the first successful population census was conducted in 1982, biologists discovered that only 22 condors remained in existence, with 21 of these were in the wild and 1 was in captivity. The birds had been disappearing for decades, and biologists really weren't sure why. Habitat loss and persecution were likely suspects. Many condors were shot, and many other condors were killed indirectly when they fed on carcasses that had been poisoned and put out to kill predators like wolves and coyotes and grizzly bears. But after biologists outfitted some of the few remaining condors with radio transmitters on their wings so that they could track the birds, they discovered several condors that had died of lead poisoning after ingesting lead ammunition fragments that they had found in the carcasses that they had fed on. When lead bullets hit and enter an animal, they lose about 30% of their mass and fragment into tiny particles, which are then inadvertently consumed by whatever feeds on that animal. It wasn't until years after the first lead-poisoned condor was discovered in 1984 that biologists really began to appreciate the severity of this threat to condors. Meanwhile, though, back in the 1980s, condors were disappearing fast. And during the winter of 1984 to 5, 6 of the 15 remaining condors, the wild condors, disappeared. Following those losses, the U.S. Fish and Wildlife Service decided to capture the last wild condors to keep them safe and to bolster a new captive breeding program. The last wild condor, known as AC9 for adult condor 9, was captured and brought into captivity in 1987. And this was a controversial and heartbreaking event for many people, since it meant that for the first time in tens of thousands of years, no condors flew over North America. Fortunately, though, captive breeding for condors, which was initiated in 1982, was very, very successful. And the first reintroduction of captive reared condors began in California in 1992. These are the first 2 birds that were released. And then in Arizona at the Vermilion Cliffs, which are just north of the Grand Canyon, in 1996. I joined the Condor Recovery Program as the field manager for the Arizona reintroduction in 2000. In addition to releasing condors to the wild, my job, along with my field crew, was to monitor the birds and keep them safe. This is the pre-release flight pen up on top of the Vermilion Cliffs where we held condors before releasing them. And this is the smaller release pen from which we released them on the edge of the Vermilion Cliffs. Once we released birds to the wild, we taught them to roost safely from predators, and we taught them to stay away from people by hazing them if they perched in inappropriate places. So the picture on the upper right hand of your screen is a very inappropriate place. Working with condors was a delight. The birds are gregarious, they're intelligent, and they're very, very playful. They're very similar to the Hawaiian Crows, which is why I think I enjoyed these 2 species so much. I really fell in love with them. So I'll just read 2 quick excerpts that might show you a different side of this enormous culture than many of you might expect. In the meantime, though, when transmitter signals indicated that a large group of condors was clustered together, I invariably looked for a carcass or a source of entertainment. After locating 11 condors on the Badger Canyon beach, I quickly surveyed the scene and breathed a sigh of relief when I saw no people, no boats, and no tents. Binoculars glued to my eyes, I sat back to enjoy the show. 2 condors played tug of war with a branch that had washed ashore. Others walked up and down a drift log, jostling for prime positions. Several paddled in an eddy at the river's edge, then sent water flying skyward as they bathed. Suddenly, Condor 196 emerged from a mid-beach condor scrum, holding an irresistible prize aloft in her bill, a plastic 1-gallon jug. She took off at a run, the other condors in hot pursuit, but with a sudden smack, 196 rammed face first into a boulder. Momentarily stunned, she sat back on her legs, still holding the jug that had obscured her view. Regaining her balance, 196 scrambled to her feet and ran on as the other condors closed in. Minutes later, 1-year-old Condor 227 commandeered the jug and flung it skyward with his bill. When it landed unexpectedly on his back, 227 leaped in mock fright and turned on his attacker. Seeming captivated by this new twist on the game, 227 again flung the opaque monster skyward, whereupon it fell back down and again landed on his back. Unnoticed on my distant clifftop perch, I laughed out loud, as captivated by the condor's activities as the birds were by their frenzied play. And then the second passage illustrates condors' intelligence in addition to their playfulness. The condor's notable but unsung intelligence was underscored for me one evening when biologist Chris Leitner returned to the field house and described Condor 127's solo play with an empty plastic bottle on the Badger Beach. Exhibiting World Cup dexterity, 127 repeatedly punted the bottle down the beach with her bill and chased after it. As she pursued it, the bottle moved closer and closer to the river's edge until the water suddenly caught it and whisked it downstream. In vain, 127 ran along the shoreline, eyes fixed on the bobbing bottle. Just when it seemed lost to her, the current swept the bottle into an eddy several feet from the riverbank. Without hesitation, 127 waded into the water and reached out to retrieve her toy, but it floated just out of reach. Looking around, 127 spotted a partially submerged boulder beyond the bottle. Extending her wings, she hopped out onto the boulder. Now, by stretching her neck, she could just reach the bottle. Nudging it with her beak, she gave it a push shoreward. As it floated toward the beach, she hopped into the water and gave it another nudge, and then another. As the bottle touched solid ground, 127 resumed her frenzied play, punting it down the beach. I know it's anthropomorphizing, Chris remarked, but 127 seemed crushed when she lost her bottle, and she seemed so excited when she was able to retrieve it and could play with it again. As entertained as I was by Chris's story, I was equally struck by 127's intelligence. No level of rote trial by error learning had enabled 127 to retrieve her toy. Instead, she had engaged in multiple steps to enact an outcome that she had envisioned, figuring out how to reach the bottle, then pushing her prize shoreward and counterintuitively away from her, step by careful step, so she could gain control of it again. I never tired of watching these birds. On a more somber note, the most critical aspect of my job was keeping condors alive, since they were at constant risk from ingesting lead ammunition in the carcasses that they found. Lead ammunition is the single greatest threat to condors. And to be clear, this is not a hunting issue. Hunting is very beneficial for condors because it provides the birds with so many carcass remains. Instead, it's an ammunition issue. If it weren't for lead ammunition, condors would be thriving. This is an X-ray of a white-tailed deer shot in Wyoming, and the black specks are lead fragments. The second photo on the right is of a shot coyote, and this is, in this X-ray, the white specks are lead fragments. So birds that fed on carcasses like these were likely to ingest small particles of lead, which were enough to poison them. If we suspected that condors had fed on a carcass containing lead ammunition, we recaptured them, tested their blood for lead, and then treated them for lead poisoning if necessary. The treatment is known as chelation therapy, and it involves injecting condors twice a day for 5 days in their breast muscle with a substance that binds the lead and helps to remove it from their body. Even with this treatment, roughly 2/3 of the condors that have died during the course of the recovery program have died of lead poisoning. And in some years, 95% of the condors in Arizona have been exposed to lead, with 70% or so needing chelation. One condor in California had lead poisoning at least 13 times. So that means it received a minimum of 130 chelation shots. Sometimes they require 2 rounds of chelation. So imagine each bird has to be netted and caught and handled and then given an injection. And it's a very stressful, traumatic experience for them and exhausting for the handlers as well. Other scavengers like bald eagles and ravens are also poisoned when they ingest lead ammunition. In a long-term eagle study in 38 states, nearly half of bald and golden eagles had chronic lead poisoning. Lead poisoning affects other birds too, not only lead ammunition bullets, but lead shot as well. More than 1,500 trumpeter and tundra swans died after ingesting lead shot that had accumulated in and around one lake in the Pacific Northwest. And as many as 15 million mourning doves die each year after ingesting lead shot that's been sprayed over fields by dove hunters. So what about people who eat hunter-killed game meat? Are they vulnerable too? To investigate this, a North Dakota doctor x-rayed 100 packages of venison that had been donated to local food banks by hunters in 2007. 59% of the packages that he x-rayed contain lead fragments. And in this picture, all these little white specks are lead. After these findings were publicized, other states x-rayed their venison donations that had been donated to their food banks, and they also found alarming levels of lead. And despite these findings, years ago, food bank donations of hunter-killed meat are still unregulated, and donor organizations don't require hunters to use non-lead ammunition. So we worry about lead in our pipes and in our children's toys, and yet every year hunters are donating millions of pounds of game meat shot with lead to the needy and eating such meat themselves, believing that they're doing something healthy for their families. And this kind of lead consumption could be having profoundly negative health and societal outcomes. Scores of medical doctors, public health experts, and scientists have highlighted the human health threat posed lead ammunition, and they've called for the use of safer types of ammunition for hunting. Non-lead bullets are now widely available. No level of lead is considered safe for people, and toxic lead effects are largely irreversible. Despite that, though, hunter advocacy groups like the NRA say there's no cause for concern. We've been hunting with lead bullets for years, and no one's ever been harmed by it. But the effects of lead can be subtle, and they're often attributed to other causes. For example, in adults, chronic lead effects include high blood pressure, decreased kidney function, and reproductive issues like impotence, decreased fertility, and miscarriage. Lead exposure can cause digestive problems and muscle and joint pain. It may be related to cognitive decline and dementia in older adults, and it affects longevity. Adults with higher lead levels are more likely to die of cancer, and they have an increased risk of death from stroke and heart attacks. In children, lead can lower IQ levels, lead to learning disabilities, and impair physical and intellectual development. So imagine how many hunters are feeding lead in meat that they're feeding their kids. Lead-exposed children have poor reading abilities, lower test scores, and a higher frequency of delinquent, antisocial, and aggressive behavior. Lead exposure has also been linked to criminality. A number of studies attribute the widespread declines in violent crime in the 1990s to the phasing out of leaded gasoline in the late 70s and early 80s. But we still have no idea if and how ingesting lead ammunition might be contributing to today's violence and crime. We're very good at ignoring warning signs that things in our environment are dangerous. We've known that lead bullet fragments are poisoning condors since the 1980s. And it's hard to imagine ignoring a bigger, sootier canary in the coal mine, but that's exactly what we've been doing. Things are starting to change. For the sake of condors, California banned the use of lead ammunition beginning in 2019, which is a great start. But it's remarkable to me that we rarely hear about the human health impacts of lead ammunition, and most states aren't even discussing the problem. Despite the perils of lead, though, there were many high points during my work with condors. In 2001, I was fortunate to document the first egg laid in the wild by reintroduced condors. News of Condor 119's famous egg was broadcast all over the country and even the world, and Discover magazine included this event in their list of the top 100 science stories in 2001. I also had the good fortune of monitoring Arizona's first condor chick. Condor 305 had the chance to be the very first nestling raised by reintroduced condors to fledge in the wild. And I won't spoil the book by letting you know if this historic fledging happened, but I will say that it was an incredible roller coaster getting to this point in Arizona, and events were even more challenging in California. Despite the existential threat that lead ammunition poses to condors, reintroductions and intensive management have significantly bolstered the condor population since its low point of 22 birds. Condors are now reproducing successfully in the wild, and they're reclaiming more and more of their former range. Thanks to the Endangered Species Act and thousands of dedicated people, these three incredible species are still with us today. The peregrine falcon is one of our biggest conservation success stories. It taught us that the best way to recover a species is to eliminate its main threat, in this case, the pesticide DDT. Not eliminating the threat to a species, a main threat to a species, undermines its recovery, as we're seeing with the California condor. But if we can eliminate lead ammunition, we'll be able to save the condor too. The Hawaiian crow faces multiple complex threats, which inevitably makes its recovery more challenging. In addition, funding and recovery efforts were inadequate for many decades until it was almost too late. Hawaiian birds, which are some of our most endangered birds, are still underfunded compared to mainland species. But the peregrine and other recovered birds have shown us that targeted conservation efforts really do work. In addition to supporting these and other conservation efforts, all of us can help birds in dozens of small ways during our daily lives. And I'm probably preaching to the choir here, but things we can do is keep our cats indoors, put decals on our windows to prevent bird collisions, avoid using pesticides, grow native plants, use non-lead ammunition, support our public lands and bird conservation organizations, and take a host of other small steps that benefit birds. By doing so, as I'm sure you've all experienced, we not only enrich our own lives by supporting the bird life around us, but we're also likely to save a host of other creatures that share our planet as well, including even maybe ourselves. Feather Trails just came out on May 2nd, and it's now available in online and in bookstores in hardback, Kindle, and audiobook versions. And I've touched on some of the more serious aspects of the book this evening, but it's filled with stories, and you come to get to know these individual birds that I reintroduce, which were just an amazing cast of characters. So with that, I'm ready to take any questions if you have them. And sorry, it was a long talk for you all to sit through. I threw a lot of information at you.
Thank you so much, Sophie, for your work in helping protect some of these birds and for sharing your knowledge and expertise with us today. I will take questions from the room, from Zoom. Any questions from the room?
I overwhelmed you all.
I just want to say bravo. Not for overwhelming.
Thank you.
Sorry, yes.
It's a lot of information all at once to take in.
Yes, I have a question.
Yes.
Yes. I've lost the screen. Hold on. Okay. Has avian flu affected the condors out in the west? I had heard some small report about the pair and their young one up at Zion, but initially, but then no other reports, as news is famous for. They mention something and then you never get a follow-up.
Yes, unfortunately, that was a really tragic incident. Aside from the parents of the chick that died, I think it was 21 or 22 condors in the Arizona and Utah population died in 2023 within a few months.
Geez.
So it hit fast, and it was just sort of an epic disaster. Fortunately, it didn't reach the California birds, and so far none of the California birds were affected. And I think they tried to really speed a vaccine development for the condors. And as far as I know, I don't know all the details, but I think they have developed a vaccine for avian flu. And I think that they have now vaccinated both populations, or all the wild populations. I think they've recaptured them and vaccinated them. But I'm not 100% sure if they have actually vaccinated all of them or if they're still testing it on captive reared. I mean, the birds in captivity, but it's in the works at least. So they've made progress. And that was one of the reasons I used to always talk about when they developed a release site in Arizona, it was in case of a big disease or something that would come and hit these birds. And whenever I used to give talks about condors, it always seems like such a theoretical, but it actually with avian flu. So it was pretty tragic. And losing 20 birds like that, they said that they probably put the program in Arizona back about a decade.
Okay, appreciate it. We saw the pair and the chicks shortly after it has started free flying in Zion in I think it was 2020. So I never heard another follow up as to whether what had happened. But thank you.
Yeah. Glad you got to see them at least.
Hi, so thank you so much for your wonderful talk. So at one point you mentioned the cost of invasive species. So how exactly do invasive species have a cost, and where does that number come from?
That was a big global study that estimated the cost of, I think, in part prevention. Like there are a lot of programs that screen, whenever you give a delivery of goods or something in Hawaii, those are screened for the potential presence of of invasive organisms. And many of them are like fungal pathogens. Like there's a tree in Hawaii that's being attacked by a fungal pathogen that came in on some wood logs that were delivered or something initially. But so part of it is screening and prevention. Part of it is treatment. Like there's a lot of places and situations where they are trying to eliminate invasive species to try to restore ecosystems and things like that. So I think the major costs come from prevention, and there's just efforts all over the world to try to, for example, remove rats from certain islands because the rats are decimating seabirds and other birds. And so that's one cost, is how much it's costing on that one island each year to remove rats, and how much it's costing to remove, a non-native fish from certain lakes. So as far as I know, this study, and I have some other numbers and some other studies in my book that focus on just the US, but this was the most recent number I had for a global study that was estimating all the costs of prevention and taking care of invasive species. So obviously prevention is the best way to go because, once it gets out of hand, the costs skyrocket. So, but we have lots of bad situations on our hands all over the place.
Thank you.
We have a question on Zoom. Sean asks, replacing lead bullets seems like a no-brainer. What is the main argument for not doing that?
I am a little baffled by the main arguments, but the NRA and other groups that are, I'm drawing a blank on all their names now, but the Shooting Sports Foundation and a bunch of the firearm advocacy groups are really, really against regulating lead ammunition. They think that it is not true, any of it. They don't think that lead ammunition is really harming condors. They think that it's basically environmentalists have manufactured an issue because they don't like hunting and they want to stop hunting. So they think that if we try to eliminate lead bullets, it's really that we're trying to eliminate hunting, which is why I always try to stress this is not a hunting issue. Most of us who work with condors are good with hunting because it provides food for the birds. It's just an ammunition issue. But the NRA and these other hunter advocacy, firearm advocacy groups have worked really, really hard to lobby to stop any regulating of lead ammunition and to stop the use of lead ammunition. So they now call lead ammunition traditional ammunition, which just gives you sort of the idea of the way they view it. And they have done a lot of lobbying to various administrations and Congress to stop, for example, the EPA from regulating lead. Over 100 conservation organizations tried to get the EPA to regulate lead ammunition. I think it was in 2010 and 2012. And those firearm advocacy organizations lobbied to stop that from happening. And they've been trying to lobby the government to never have any federal agencies regulate lead. So it's infuriating, and it's a crazy situation, but it made me, COVID opened my eyes a lot to how these things, that make sense to some people, like vaccines might be a good thing, but then there's a bunch of people out there who think they're not. So that's what's going on with lead ammunition, and it's really frustrating. So
it's interesting that in New York State, you can no longer use lead as sinkers to fish with.
that's fantastic.
Yeah, although it's interesting, you can use it, but you can't buy it in New York State. So if you
Okay. Well, it's a start, I guess, because those lead sinkers have caused a lot of problems for loons and other water birds. So, that's something that I know non-lead advocates have also been trying to get rid of the lead fishing sinkers as well. So any progress on that front is great too.
Yes, but on the firearm side, from what I understand, and I'm not a hunter, but from talking to hunters, the lead ammunition kicks more punch. It's a denser material, so it will kill the animal easier, I guess.
Are you saying non-lead?
No, I'm saying lead.
Oh.
Because lead is denser and heavier. It has more punch than steel, or I guess I could use titanium, but that might be a little expensive.
They've done a lot of, that's one of the myths, actually. They've done a lot of studies, like with copper bullets, and they have bullets that have as much killing power as the lead bullets, and they're really effective and they're really accurate. So they actually are really good, high quality bullets. And because they don't fragment, bullets like copper bullets actually have more killing power and are better, actually, than the lead bullets. So
it's interesting, at the wildlife management area near me, Assunpink, on the shooting range for shotguns, you are not allowed to use lead shells. You can only use steel.
Yeah, that's great, because that used to be a major concern, and I think it still is in a lot of places, the shooting ranges and the lead there, and that lead has seeped into the grounds, and it's affected wildlife in those areas as well. But it does seem like there's starting to be some awareness that at least in shooting ranges, that lead is not a very good thing. So any progress is great, but it's just being very, very slow. And it's just amazing how little it's dealt with.
Do you have any questions in the room? Any on Zoom? You can unmute yourself.
Yeah, I'd like to ask it. I'd like to ask a question, Naveen.
Go ahead.
Yeah, you touched on the range of the condor in your talk, and I think I caught that you said that the condor used to have a range that included basically the whole country, or if not the whole continent. And then I think you said it was because of the decline. Is it the decline of megafauna that restricted the range?
That's what the hypothesis is, yes. That as the Pleistocene megafauna died out, that restricted the range. So
okay. Do you know why it did hang on in California then? Did megafauna last longer in California, or is there any theory on that?
the theory seems to be that in California, they were feeding a lot on marine mammals and coastal species. And so that was part of the issue there. I don't entirely, you know, there were still pockets of condors, you know, into historic times. And there are some people who say that condors were completely restricted to California as the Pleistocene megafauna died out. And then condors recolonized part of the Western US once settlers brought cattle, and we had these huge cattle drives and huge thousands upon thousands of cattle in the West. And that kind of allowed condors to have another food source. And so they recolonized, you know, Idaho, Montana, Grand Canyon area, Arizona. They were in those places until like the 1920s. But I don't know that they entirely died out, you know, before those cattle were kind of driven all over the landscape, because to me, it seems like condors are such opportunistic animals. They feed on such a wide variety of food where I worked with them in the Grand Canyon area. I mean, I suspect that there may have been, their range certainly contracted, and most of them were in California, but there may have been occasional ones or some few that were hanging on in some of those other parts of the West for longer than we're aware of, I think.
Are there any serious considerations to try to restore them to other states, other mountain states, western states, etc.?
Not yet that I know of. There is the new release site in Northern California, so they should be going up into Oregon soon. But I haven't heard about any attempts like in Idaho or Montana. I was in Wyoming when one condor from the Arizona and Utah population came and visited, so that was sort of amazing. But yeah, so far it's just sort of the western part of their range. You know, if they go up into Oregon, that will be amazing because it will be from Oregon down into Mexico, and then as far east as the Grand Canyon and Utah area.
Thank you.
So if you have one last question,
Thank you.
nothing else.
Yes.
I was reading your book, I was particularly touched by the story of the alala. And I think you mentioned that they're probably going to be reintroduced on Maui this year.
Mhm.
Is there any place that you know of where I can keep up to date with these efforts? The Hawaiian Crow, like, is there a good place, like a single source or something?
There is a group called I think it's called the Alala Project, and they post updates periodically. But I have to say that I usually just have to Google things. I have found that the Alala program is not very transparent. Like for condors, every year they put all of the hatchings, the deaths, what birds died of. They put all of the information online, and it's the most transparent and visible sort of program that you can access. I had an incredibly difficult time getting information about the crows. One of the main groups that's in charge of them wouldn't allow me to speak to any of the captive breeding people. They wouldn't let me they wouldn't answer my questions. It's not a very transparent program, which I think is super unfortunate, because I think the crows need all the help that they can get from us. But the best group I know right now, and it does put periodic updates, is the Alala Project, I think. And so if you Google around, you can find them, and they at least will keep you apprised of the biggest events in the crow world. So all I know from right now, as far as I know, they have done the environmental impact studies, and they've had the my screen just peeled off my window, so I'm now being beamed in the face, sorry, by sun. But they've done the environmental paperwork, and as far as I know, they've been basically cleared to go ahead and start that reintroduction. So I don't know when exactly it will happen this year, but hopefully soon. And I'm really happy that you got touched with the crows, because they are just incredible. I'm glad you appreciated that section of the book.
Yeah, they sure are, and people aren't familiar with it here. I highly recommend reading about them.
Thank you.
No more questions? All right, thank you so much, Sophie, for.
Thank you all. Thank you all for coming. I really appreciate it. And thank you, Naveen, for taking a chance on me since you hadn't read my book before you invited me to come. So thank you.
It was great. Thank you so much, Sophie. Appreciate it.
Okay. Bye.
Bye-bye.
Do you have anything to add? Bye, everybody on Zoom.
That was anticlimactic.